Hey folks, this is a YouTube version of the solution to the practice problem that I gave for test 2. What we have here is a representation, although it's in perspective, is analogous to the Fisher projection, which was given as compound Q. And what I'd like you to do now is to mark the blue, a B for instance, here as a methyl group, and the yellow over here, Y, as ethyl. These are hydrogens, these are carbons. The red over here will be an OH, and you can represent this green over here. That's the Br. You can put a G there. Mark up the solution that you've printed out with the designations B for methyl and Y for ethyl, and R for the OH, and G for the Br, and that'll help make this all make sense. So here we have the Fisher, here's the vertical, and here we have the horizontal. And what I'm going to do now is I'm going to rotate this just a bit like this, and here we go. So I'll give it a little twist like this, and then a bit of rotation like this. Of course, you can follow along with models. And what this does is it puts us in position to look at the diagram that you see to the right of compound Q. Over here we have our methyl, and I'm going to rotate that now 180 degrees upward. And so as we do that, what's going to happen is, if I do it right, there we go. That's not quite what I want to do. There we go. Okay, so we're rotating it now straight up like that. Perfect. And let's turn this around a bit here, like this. Okay, that's pretty darn good. This, of course, represents the Newman projection that you see on the extreme right, and to put it back into the perspective, we can rotate it like this, and you can see it there. Over the course is the methyl, and here we have the OH, the H, the Br, and of course Y. If you want to, you can pause this and use a set of models to help visualize this, because R&S might take too long if you try to work out 8 or in this case possibly 10 chiral centers. So this here is going to be the compound on the extreme right, and now we're going to move on to the compound just below it, which says it's identical to compound 4. In order to do that, I'm going to do a rotation of this carbon in the back here, and what I'll do is I'll move that methyl group now down a little bit, and here we go. So there's that methyl group moving down. Perfect. So let's do it again. Move that methyl group down like that. And this, if I move it over a little bit like that, perfect. That is the Newman projection that is said to be identical to compound 4. Okay, so let's see what else we can do with this. Let's take a look at the one that is the enantiomer of compound 2. That's on the second line on the left-hand side of the page. What I'm going to do here is I'm going to bring the methyl group forward. So I'm doing a rotation like this, and you can always pause and rewind the vid if you want to see it again. And we're going to be moving this methyl group upward, so bring it up a little bit like that. There's the methyl group pointing straight up. There's the Br, the H, and the red is the OH. And so once we have that, what we can now do is we can bring the bromine, which is here in green, to the position where the ethyl group is. So I'm going to select another carbon to do that, this carbon in the back, and then let's see what happens. Okay, and there comes the bromine going down. Perfect, and let's square this. Now it's square, and we can see the two hydrogens over here on the right, the ethyl, the OH, the methyl and the Br, that represents the Fisher projection, which is going to be, that represents the Newman projection, which is going to be the enantiomer of compound 2. Okay, well, now let's go ahead and take a look at the one on the bottom line, the diagram, which is a perspective, and this is the diastereomer of compound 3, which has the ethyl group on the left-hand side. So the ethyl group is going to be the yellow group over here. So what I'm going to do is I'm going to move that around so that the yellow group is on the, what I should have said, left-hand side. There we have the ethyl group on the left-hand side, hydrogen going back, bromine coming out. And then we're going to use the methyl group, which is blue, right over here. And over here we have our OH with the hydrogen you can see there behind it. And this represents the diastereomer of compound 3. So all of these are compound Q. And by making sure we have a methyl group and we have a bromine in the in-plane positions, we find it easy to compare this molecule to the answer keys. So the choices on the answer keys, that is. Now for the final one, which is going to be on the bottom right, it says the enantiomer of compound 1. So what I'm going to do now is I have, in this case, the methyl group, which is going to be on the left. There's the methyl group currently on the right. So what I'll do is I will rotate this around like so, so that the methyl group is going to be on the left. And what I want to do is bring my hydrogen to the top position. So I'll select this group here and I'll move the hydrogen up like this. And if the program will let me do it, I'll be very happy. There we go. Thank you. So now we have the hydrogen coming out, we have the methyl group going in, and we have the OH in plane. And if we rotate it just a little bit more, we can get the hydrogen in plane now with the methyl coming out, over here, and there's the OH. So the left-hand side of the molecule is perfect, and the right-hand side has a bromine over here. And then what we have is we have a hydrogen coming out, and we have an ethyl group, which is going back. So that's perfect. That is the enantiomer of compound 1. And if you use models and you practice this, you can get very good at it and be able to do it very quickly without a lot of stress and strain. A lot of problems, R&S will work great, but for this type of problem, R&S, although it can be done, will not only take a lot of time, but also wear you out and make it very likely that you will either make a mistake on this problem or on a subsequent problem. So I strongly recommend, in the interest of time, that you learn these skills for selective problems. That's all, folks. Thanks.